Part number 1, you have the bridge. Crack on. You can never play later. You're now host.
Thank you. Record to the cloud. Right. Okay, good evening, everybody. Welcome to this extra webinar on exam technique. It really is very, very straightforward exam technique. I'm going to really remind you of a lot that you probably know anyway. But the funny thing is, when people take exams, they forget all this advice and hints. Because I see exam papers in the summer where I mark international GCSE for Edexcel, and I mark BTEC papers in the autumn winter, and students don't follow these very simple instructions. Really, it's 3 parts: exam technique, preparation, reading and writing, and arithmetic for those of you in the know. Now, I'll just put a little point to the right-hand side there. I wrote this predominantly for GCSE Astronomy students, but much of what I'm going to say, much of the advice and all the hints apply to many science subjects in general. Okay, now some of you taken exams a long time ago like me. I forget when I took my last exam, crumbs. Don't know. Some of you have yet to take proper exams. You might have done SATs in year something or other. Some of you, in a few weeks' time, are going to be writing GCSE Astronomy papers, and I'm going to be giving you estimated grades. Some of you will be taking exams maybe next year, maybe the year after. So welcome everybody. Although it's astronomy, a lot of it does apply to science in general. And as the teacher says, it's all in the preparation. All right, it's all in the preparation. Good. Right, let me get rid of that little thing there. Now, before you go into the exam, you need to have just 3 things. You probably have a little slip of paper as well, giving you a candidate number. But you probably won't be doing this actually, because you'll be taking these exams either at home or in some invigilation centre, or you'll be observed on Zoom or something like that. But this is for future years as well, not this crazy year or a couple of years when we have the pandemic. And you need black pens, okay? Black ink, because that scans better than blue ink. You need a ruler, and probably you'll need a calculator. There aren't very many complicated calculations, but really you do need a calculator just to check. Now, you won't need anything else. You might be drawing diagrams, but you won't need pairs of compasses to draw circles. You can draw circles freehand, or you can draw around a 10-pence piece or something like that. You won't need set squares. You won't need protractors, even though there'll be a lot about angles. So just leave those at home and just take everything else in a clear paper bag. There's also something else you're going to need, the formulae and data sheet, but that's inside the paper. It's usually a tear off, it's sort of perforated, you can tear that out. Okay, so that's the only equipment you need to have. Something to write with, something to measure distances with. Maybe you've got a picture of the moon, you've got to measure in millimetres the diameter of, say, the Sea of Tranquility. You've got to measure in millimetres the diameter of the moon, and then you can work out the ratio of those diameters, something like that. So ruler and then calculator to do the calculations. I still see some who do long division and long multiplication and things like that. Goodness knows what they're going to do when they come to standard form numbers or square roots or things like that. But there we are. Right. So you are given formulas and you are given data about the solar system and about distances and things like that. All right, so you won't need to remember any formulae. The equation of time, Hubble's redshift formula, all those are given for you. And also, I'd like you to be very aware of what kind of questions you'd be asked. There's a whole range of question types, really, to suit everybody. There's usually 3 or 4 questions at the beginning of the paper. Now, this wasn't the case in the sample assessment material, but in recent years, in the last 2 years, the examiners have put the multiple choice, most of them at the beginning. Sometimes in groups, sometimes just random. So there might be a question, say, which quantities would you plot to prove the Hubble law? And one of those would be velocity against distance. And then you might have, a student carries out a shadow stick experiment 3 degrees west of Greenwich. At which time will the sun be blah, 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 blah? Nothing to do with cosmology. So they might be in little groups. They might not. At the other end of the scale, you've got a couple of what we call 6 markers. It's pretty obvious why they're called 6 markers, because you get 6 marks if you get everything correct. But these are marked on something called levels. So the examiner will read through what you've got and look at the content and then think, does it all make sense and link together? And is it written nicely? And then you'll get sort of, an appropriate number of marks. They're the ones that examiners don't like at all, but they're in there because we have to teach various assessment objectives and things like that. Don't worry about all the educational stuff. So there's a couple of marks where you'll be expected to write something. Now, these are usually testing your observational skills. Okay, remember that portfolio of work that you have to produce? Well, that is really so that it can help you in the examination. So you might have to plan an observation, maybe to observe a meteor shower or something like that. All right, so you've got to think, okay, which meteor shower will I study? From where will I observe? What other choices do I have? Why am I choosing this one? Probably because it's handy and it's in the back garden or something like that. How am I going to record the meteors? You're going to get a piece of paper with a star map on, but not too many stars, and so on and so on and so on. You might be given some data to analyse. You might be given some apparent magnitudes of stars in a constellation, and you might be given a student's estimate and be asked to comment on that. Is he or she being too generous in thinking stars are brighter than they are? Or is he and she thinking, oh no, the stars really are quite bright. I'm going to, give them all magnitude 1 and 2s and things like that. Okay, so that's the sort of thing that you'd be asked, and there's 2 6 markers. In between, there's all sorts. Short written questions, little diagram completions, drawing from scratch, identifying the Sea of Tranquility, the Ocean of Storms, the Pennine Mountain Range on the Moon, this sort of thing. For a freehand drawing, you might be asked to draw the relative positions of the Sun, Moon and Earth during a lunar eclipse, something like that. So you just make sure that the 3 circles are in a line and that the Moon is on the opposite side of the Earth from the Sun. It's as straightforward as that. Right, so that is the preparation. Knowing what to take in, and also, I guess, knowing what to expect in the questions. You are given novel situations. The examiners take great pride, I think, is maybe the word. I wouldn't perhaps use that word myself, in trying to come up with questions that nobody has seen before. And they just touch on the sort of straying off the specification a little bit. But don't be put off. They are astronomy questions. Here we are. I've just dug this out from a couple of years ago. I've not got the whole of the question here, but this is the Greek astronomer Poseidonius made the following observations of the bright star Canopus, looking due south on the Isle of Rhodes, and so on and so on. You may never have heard of this Greek astronomer. You might not know the bright star Canopus. You might not know where the island of Rhodes is. Somewhere in Greece, I think. From Alexandria. Where on earth is that? Well, we know where Alexandria is because we know the work of Eratosthenes, but this is just leading in. Don't be put off by these 3 sort of sentences here that you may never have heard about. Don't worry. Okay? Don't be put off. It's all astronomy. So obviously some person, some astronomer, it doesn't matter who he is, what nationality he was, is going to observe from two different places, and the altitude of a star is going to be different because obviously he is observing from different latitudes. So it's all to do with latitude, altitude, and not about Rhodes and Canopus and Poseidonus and so on. I hope you're with me there. Don't be put off. Don't be put off. And of course, the only other thing you need is that you can understand the astronomy that you've learnt and apply all the principles. Okay, so don't be like these two, looking very worried. And not all pupils, some are almost ready. Young Jimi Hendrix there is looking a little bit worried. Good, right, okay, we're on to reading, everybody. The advice that all teachers give to students, I know I was a teacher for 35 years, read the question. Actually, they're not questions anymore. They are commands. State, evaluate, calculate, suggest, analyse. You only get questions at the beginning of multiple choice. You know, which of these is blah, 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 the correct answer. Now, it's very important that you understand what to do when you're given these command words. That's what they're called in educational jargon. The syllabus, the specification, lists these, but I've actually produced a sheet, a slightly more user-friendly version of this. And if you'd like it, there it is, command words. Just send me an email, or perhaps I'll send it to Alistair, who might kindly put it on the VLE. But this is just command words. This is a list from the New Pupil Toolkit that I've published. But there's a lot of command words, and a lot of them are very similar. You know, what's the difference between describe and explain? Well, we'll have a look at that in a moment or two. So you've got to know what to do. You've got to know what to expect. Let's just go back to some of those command words. All right, calculate is easy. Suggest is easy. Come up with something. Evaluate means weigh up, say, a conclusion. You know, a teacher might say, there are two major groups of planets in the solar system. The 4 terrestrial planets and the 4 gas giants. And then the question might say, evaluate the teacher's comments. There we go. So you've got to dive in and think, what's right, what's wrong. Excuse me, just having a sip of my tea. Analyze is a popular one. They might give you a table of data. Some moons around Saturn. You've got to analyse this and think which moon might be most suitable for having an atmosphere. You know, it's not going to be too hot, and it's going to have sufficient sort of pull of gravity and so on. Right, so command words. There we are. I'll just flick over my suggestion there. Quite a lot of them. Some are not really applicable to astronomy. This is a kind of generic list that edXL produced, but there are a lot in here. So you're going to be commanded now, not asked to do things in a nice kind of way. Now, another thing that really we need to do carefully is look at the marks. Students, don't do this. And it's crazy, really, because if you've got a 2-mark question, you need to either draw or describe or state 2 things, or you need to describe something and give a reason, which is what explain is. So each question itself, 1, 2, 3, 4 down to 10, is split up into several parts. So there's parts A and parts B, and there's sometimes what we call dotty 1s and dotty 2s. So there might be questions 7A dotty 1, A dotty 2, B, C dotty 1, C dotty 2, and so on. Okay, they're trying to link together. Now, the mark for each part is given, and that's what you need to judge how much to write. And basically, if it's a description or an analysis or something like that, it's 1 sentence per mark. If it's a calculation, really, it's often sort of 3 marks. One for identifying the right formula, one for substituting the numbers or rearranging, and one for getting the right answer. So that's the calculations are straightforward. But if it's an explain, and you've got 4 marks, really, it's going to be a couple of marks. A couple of sentences for you to describe what's going on, and then the explanation bit. All right, explain why meteor showers occur at certain times of the year. So meteors are caused by the Earth intersecting a meteor cloud, or a cloud of meteor dust, meteoroid dust, of course. And when these burn up, blah, 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 you can do the explanation bit there. Or you can do the explanation bit. These clouds only occur at certain parts in the orbit of the Earth, because the Earth is intersecting the wake of a comet, something like that. So the marks and the command word are vital. Okay, so here we are. 2 things are important. Explain means a reason should be given. And the marks, 2 marks means 2 sentences. All right. And if you like writing long sentences, I would suggest that you split them up into 2 shorter ones. Make it easy for the examiner. So we've got the command word, explain, and we've got 2 marks for the mark. All right. Don't just glance over them. Explain blah, 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 why the pointess is not in the constellation of Cancer. And then 2 marks. Oh, well, I'm just going to say it's not in the constellation of Cancer because it's in the constellation of Leo. Well, that's not an explanation, is it? And that's not worth 2 marks. I've only said one thing. We'll come on how to write these a little bit later on. Right, everybody. Good. Hopefully this is going well. These are obvious points, as you know. Here we are, another one. This time it's a description. Describe. Don't need to explain anything. Describe a safe method of observing the sun when using a telescope. So it's no good writing use a pinhole camera. I mean, they're not very good anyway. That is not a telescope. Okay. And again, there's a hint. You may include a carefully labelled diagram. That means draw a diagram. All right. It's worth 100 words probably. So a telescope with a filter, an H-alpha filter, or using the projection method, something like that, easily drawn. You know, just draw the telescope as a tube. There's no need to draw anything else. Piece of paper, a baffle on the top of it. Easy. Draw a diagram, and you get the marks for that. Much easier to draw than to say, as you just heard from me. Well, here's an example of the objective question. They've always got 4 options. Okay? Now, read it carefully, and when you think you've got the right answer, just read the wrong ones again and just make sure they're wrong. So I'm going to look at this question and think aloud. Okay, which of the following is located furthest from the sun's surface? The chromosphere. No, it's not that. That's next to the sun's surface. The corona. Oh, yes. Not the penumbra. Penumbra is something to do with sunspots. And the heliosphere. Oh, now then, I'm reading it carefully. The heliosphere is the region that contains the sun's influence. So the heliosphere stretches way out beyond Neptune. That's much further than the corona. So let's go for option C, the heliosphere. Let's just check. Chromosphere, no, that's next to the sun's visible surface. Corona, no, that's the outer atmosphere, but is much, much closer to the sun's surface than the heliosphere. And I don't know how penumbra went in there. That's just a red herring. They ought not actually to give you an option that just isn't correct. They should all be plausible. All right, when I used to write the paper, they were all plausible answers. So read the others very carefully, please. Okay, just make sure. Good. Nothing to stop you putting ticks and crosses on the right hand side. It's only the box with the little faint crossing that will be marked by a computer. Or, well, not this year, it'll be marked by me. So, there we go. Oh, a 6 marker. Here we are. An observer wishes to make some measurements of the size of the equation of time to see how it changes during the year. So, this is a little bit of a twist. You need to understand what we mean by the equation of time. So, this question is testing how you might work it out. Okay, so you've got to design a suitable observing program that will allow the observer to produce a series of measurements. So what are you going to use? Where are you going to observe from? When are you going to do this? All the stuff that's selected from lists. Okay, those of you who've sent me your observational skills and I've responded, I've probably suggested that instead of saying I'm going to observe from such a place on such a date, give a list of possible dates and possible locations and select one. Okay. Now, the important thing here to read is at different dates, at different points in the year. All right. The objective is to see how the equation of time varies during the year. Okay, you could get a chart of the equation of time. That's not what this is asking you to do. This is effectively producing your own equation of time. You know, the big drop and then the little rise and the little dip and then the big rise through the year. Okay, and as I say, you get 1 mark for writing everything in a nice logical manner and using the correct astronomical terminology. So don't get your apparent and your means mixed up. Right, okay, so that's all the reading stuff, more or less. So this student's very astute. All we need to do is read everything carefully, but focus on the command word and on the marks. Okay, so obviously this teacher has hammered into this young lady read everything but the command word and the mark. All right, good. So let's now look at writing, how to write your answers. How to convince the examiner that you know what you're talking about. Okay, so as I say, try to use short sentences. I've developed this knack of using short, zappy, sort of staccato sentences. Not when I'm talking, you know, over this webinar and so on, because we don't really speak in sentences. We go all over the place. I do anyway. Short sentences. You know, Galileo used a telescope. Galileo observed the sky. Galileo, or he wrote down and sketched what he saw. You know, 3 short, zappy sentences then. It makes it easier for the examiner to put little ticks on and tot up the marks. One thing you mustn't do is this bottom of the page here. I see this so often with GCSE papers. Avoid repeating what's in the question. It's absolutely bonkers writing the words of the question. So this one, explain why point S is not in the constellation of Cancer. Point S is not in the constellation of Cancer because that will take you half a minute to write and gets you no marks whatsoever. And yet I see it as an examiner time and time and time again. All right. Now, maybe the student doesn't know, so is hoping to get some marks by repeating the words in the question, but we examiners are no fools. Okay. We might have an answer, the Earth's axis precesses, or the Earth undergoes precession. Remember that from yesterday, everybody? 1 mark. Okay. So the alignment of the equinoxes is no longer with there's a star in Cancer, something like that. We haven't got the whole question here, but this was a question to try and spot whether or not students could identify that precession was occurring. So don't start it off with point S is not in the concept, because just waste of time and no marks. You're forced into a corner. So here we are, the astronomy. The Earth's axis undergoes precession. This makes the stars move over a long period of time in relation to S. How's that? 2 short, zappy sentences. Even if you wrote the word precession, you might just get 1 mark. But I would prefer you to write the Earth's axis precesses or undergoes precession. But we're not testing, English here. That's done in other papers. Okay, let's look at the another previous one. Describe a safe method of observing the sun when using a telescope. So the command word is describe, and it's not explain. Now, I haven't done a diagram here. I'm going against my own advice, but this is in case you want to write things instead. So use a Mylar or an H-alpha filter. That will get you 1 mark. Okay, for identifying what you need to use. Now, what it does is absorbs most of the light. So the alpha filter just allows a small wavelength range of light through, and the Mylar filter absorbs everything and just gives you a sort of much dimmer images. But we don't want, because we don't want to reason. It's not an explain question. All right. You might think, oh, well, I want to, show the examiner what I know. Don't. It wastes time. It does absorb most of the light, either of those filters, but that's not what the question is. It's describe the method. That's it. That's all. Look at the question. Describe a safe method. So keep your eye on the question. I always read the question again at the end and just make sure I've answered what is asked. So the other one might be, where do we put this filter? Well, easily to show that at the top of the telescope before the light comes in. That will give you the 2nd mark. It's a description of the technique that you would use. All right, everybody, we're on a roll here. Let's see if there's any more. Oh, here's a nice one. These are taken from exam papers, by the way. Declination and right ascension. So we've got the sort of grid for a star chart. This is quite not letting on that much from the poles, but this is quite a curved little chart here. If you get a star map of constellations near the North Celestial Pole, Cassiopeia, Draco, Ursa Major, Ursa Minor, the grid lines aren't sort of rectangles. They are, I don't know what these are called. Somebody can tell me a little bit later. Keystones, I think. No, not a keystone. Keystone has a flat bottom, I think. Oh, I'm not sure what they are. Please tell me somebody later in the text chat, please. Yeah, so analyse figure 4. This is figure 4, by the way, to determine whether the grid shows part of the northern or the southern hemisphere of the celestial sphere, and explain your answer. Ooh. So there's like two command words in one. This has come up in the last year. I don't like this. I'm going to complain to Edexcel if it happens again. So analyse figure 4 means have a good look at figure 4 and have a rummage around and see what you can find. Oh, the declinations are negative. Excuse me. The declinations are negative. So this means that we're in the southern hemisphere. So I would write southern hemisphere, declinations are negative. That's all you need. Oh, there we are. And that's what I've written. Southern hemisphere, so that's your conclusion. And your careful study has let you spot that. I think analyse is a little bit over the top myself. I think just a casual glance would show you that the declinations were negative. But never mind. Never mind. A negative declination means that they are south of the celestial equator. Right, there we go. I hope you're getting the idea of all this. Oh, now then, a diagram completion. Describe what's meant. when a star is said to culminate, and use a clearly labelled diagram. This time you have to draw a diagram because it says so. You are commanded to use a clearly labelled diagram. Well, I would draw a sketch. You see these in the textbook and in some of the other material that we published, of an observer looking south. Probably easiest to relate culmination with a star in the south reaching its highest point when it crosses the observer's meridian and it's due south. All right, so all those things in bold there, a couple of those I think, because it's 2 marks, you might not need all of them. So let's look what I've drawn here. Okay, so we're looking south, we've got the familiar hills, we've got east and west marked on. So let's just make sure that's the right way. I often get east and west mixed up. Goodness knows how I led an expedition across England. A walk called the Coast to Coast walk. I don't know my east and west. I suppose we would just kept going in the same direction, really. That was west to east. Right, the star crosses the observer's meridian. And at this time, the star has greatest altitude. Okay, 2 marks there. Star crosses the observer's meridian isn't quite the most accurate. That is actually just the observer's meridian. So it's a line from due south and it's going upwards sort of over the observer's head. So anyway, it's crossing the observer's meridian and it's highest in the sky. It's got its greatest altitude. All right, 2 marks. Right, okay. So these students are very keen. They want to do some marking as well to see if they can read what the students are saying. So let's go for it. Right. So this student, in response to explain why light from the Andromeda and Triangulum galaxies is blue shifted, has said they are not distant galaxies. They are moving towards us. We don't want the wavelength of the light is shorter than it should be because we're told that the light is blue shifted. And what I've suggested is that both of those are very good. So they're not distant galaxies. They're in our local group. You know, you see nice images of Andromeda. You can see Andromeda with the naked eye. If you use a bit of averted vision, and a small telescope will reveal it. Even binoculars. And the Triangulum galaxy as well is one in our local group. We should know some of the names of galaxies in our local group. So they're not part of the expansion of the universe. They're gravitationally attracted to our own galaxy. And the explanation is they're moving towards us. That's all you need. The same question. The wavelength is shorter. The galaxies are expanding. Well, I've more or less just hinted on whether or not we should credit the wavelength is shorter. That's just repeating the question. Not literally word for word, but it's not blue shifted because the wavelength is shorter. Those are 2 explanations. Those are 2 descriptions of exactly the same thing. Another galaxy is expanding? Well, unfortunately not. No, that's an incorrect statement. Okay, another one. State the reason, so just a statement, why the dish in a radio telescope must be made from metal, and explain why the dish in this radio telescope, there was an image of Jodelbank or something like that, I think, needs to have a much larger diameter than mirrors in the largest optical telescopes. So why are radio telescopes much, much bigger than optical telescopes? Right, metals are used because they're shiny. Metals are shiny, unless they're dull metals. And to collect lots of radio waves so that you can see the image. Now, I'm giving you student speak here. So we've got to interpret a little bit. I know that's not a sentence. And you might not want to be, but that's the sort of answer we get, and we make we make allowance for that. So metals used because they're shiny, 1 mark. Explain through 3 marks. Look. So we've only got 1 sentence to collect lots of radio waves so that you can see the image. I don't think that's saying 2 things, and it's too vague anyway. So how did I mark this? Not shiny. We'll look at a better response later. And I don't think there's much credit worthy there. You don't see an image anyway, you look at a contour line map. Okay, a better attempt. Metals are good reflectors of radio. Presumably waves would allow that. Looks okay. Oh, radio waves have a greater wavelength than visible light. The resolution, always a good word in your answers, everybody, resolution, the ability to see detail, depends on aperture size and wavelength. So this gives, so the fact that there's a longer wavelength means that they need a big aperture to compensate for the wavelength. You might put that in as a sort of justification. That would give an almost complete full answer. But I think that's a good 3 marks. So certainly good reflectors of radio waves. And radio waves have a much greater wavelength. So because of that, to get the comparable resolution, we need a bigger aperture. I would give all that 3 marks. We've got another one. Metals are good reflectors of radio waves. So the students put the waves in now. And the explanation, radio waves have a much longer wavelength. High resolution is proportional to diameter and proportional to 1 over the wavelength. Large diameter compensates for the wavelength to achieve high resolution. That's a good 3 marks again. That is a kind of something that more perhaps mature students with more experience might write about. And I know we have 2 or 3 of you who are taking the exam this time. So there'd be nothing wrong in writing something so fluent and so impressive. Okay, big D I assume is diameter. I'm okay as an examiner with that. Alpha means proportional to. There we go. Nice answers. Yeah, of course, 4 marks. A few more questions like that, and you know we're in with the high grades. State why constellations Gemini and Cancer are referred to as zodiacal constellations. 1 mark, just a statement. And this student says, because they're constellations of the zodiac. Now, what's wrong with that? They are constellations of the zodiac, but that's just repeating the question, isn't it? Why are they zodiacal constellations? Because they're constellations of the zodiac. No, I don't think that's showing any astronomical knowledge or understanding. Because the ecliptic passes through them, so the sun moves through them, I think is fine. All right. The ecliptic intersects them. They stagger the ecliptic. All right. The sun and planets are found in these constellations. I wonder what you would think about that. I think that's a perfect answer, even though we've not mentioned zodiacal. Because the constellations of the zodiac are those constellations through which the sun and the planets move, or appear to move. Right, everybody. So, a little summary. Prepare. Make sure you've got all the equipment. Okay, you don't need a pencil. You don't need a blue ink. You need black. Okay. And make sure you know what to expect from the styles. So a good read of the command words. Look at the command words and the marks available. All right. Read the whole thing, obviously, because you've got to understand what's being asked. You know, that emphasis on the equation of time at different parts in the year and so on. Everything is made really easy for students. It's just a pity that they make it complicated for themselves by not reading things carefully. Use the command word when you're writing. Okay, so if you're writing the answer to an explain, we need the word because, or the reason is, or something like that in there. Short sentences, diagrams if you're advised, or if you're told, of course, and don't repeat the words in the question, and, write clearly, don't be vague. How does the appearance of the Pleiades look through a telescope? The stars are bright. Well, what does that mean? How bright is bright? Okay. How long is a piece of string? I told my teacher once, it's twice as long as half a length. Write clearly. All right, you've studied astronomy or some other science, and here's your big opportunity to get all those ideas in there to an examiner. Don't be vague. Good. Right, okay, ladies and gentlemen. Good luck in the exams to come. You've got this presentation from now on, so it will be available on the VLE. It really is very simple. I've spent a lot of time just reinforcing the main ideas that we've had. So there we go. I hope that's really useful for you in the future. And if there's anything you want to query, please let me know, or please put in the text chat as we've got this evening. That's brilliant, everybody. Good. Thank you very, very much for your participation.